Hey everyone, and welcome back. In this lecture, we'll go through and look at how we can automate calculations inside of Excel using formulas and functions. Let's start by looking at what formulas and functions are. A formula is an expression that can be used to perform mathematical operations on data inside of a worksheet. Some good examples of formulas include addition, multiplication, subtraction, and division. A function is similar to a formula, but could take on some different functionality. And again here, a function is a predefined formula that performs calculations by using arguments. Going back to our spreadsheet that we were working on in the last lecture, we'll start off by creating a new column that will automatically calculate the gross pay for each of our employees. And gross pay is simply what an employee earns before tax, and it can be calculated by multiplying their hourly wage by their hours worked. Before we do that though, let's look at another formatting option available inside of Excel. In column E, we have our hourly wage data, and this should be formatted as a currency, but it's currently just shown as a regular number. To change this, we'll format the column to display numbers in a currency format. We'll begin by selecting the entire column by clicking on the column identifier, which is column E, and then up here in our number group on our home ribbon, we have the accounting number format button, which you can see here. And this option allows us to format numbers inside of our spreadsheet as a currency. So we'll click on this and we get a few options. So we either have British pound, US dollar, or the euro. Alternatively, you can access more currencies by clicking on the more accounting formats option and then opening the symbol drop-down menu here. As we go down the list of choices, you can choose pretty much any currency from around the world. But for our spreadsheet, we'll just go back and choose the US dollar. Okay, and with that done, let's go ahead here. And in cell F1, we will enter our column heading, which we'll call gross pay. And here, Excel has automatically identified and continued the formatting for our column headings, so we don't need to change that. And now we can create our formula. And to create our formula, we first need to initialize it and tell Excel that we want to use a formula as opposed to entering or writing plain text like we have been doing. To do this, we can use the equals sign, and the equals sign is also used to initialize functions. We'll have a look at that shortly. In cell F2, let's enter our equals sign, and then we'll enter in the hours worked for this particular employee, which was 38 hours. And next, we'll multiply the hours worked by their hourly wage, which is $16.40. And notice here that I use the asterisk symbol for multiplication. So this is very common within programming languages to use the asterisk for multiplication. If you go ahead and press enter, we can see that Excel has automatically calculated this value for us. And if we bring up a calculator, we can go ahead and verify that this is correct, which we can see here that it is. If we were to update the hourly wage for this employee, their wage would not update. And this is because we've entered a fixed or absolute value into our formula. So instead of entering $16.40, we should instead enter the cell reference, which would be D2. And this way, when we update the salary, our formula will also update. So let's go ahead and make that change now. And we'll also, while we're at it, update the second part of our formula, which is the hours worked, to use the cell reference too. Also, instead of entering our cell reference manually, we can also click on the cell, and that will input it for us automatically. We can go ahead now and press enter again. And this time here, well, you can see you get the same result, but this time the value is dynamic and will update when either the hours worked or the salary changes. And the reason this works is because Excel is just reading the value currently found in that cell. So if you go over here to a blank cell and say that it's equal to cell D2, it'll return the same value. So Excel is just feeding this number into our formula. And let's now use what we learnt in the last lecture about autofill to create this formula for each of our employees. Like last time, all we need to do is select the cell and drag the little square, so the autofill handle down, and then Excel will automatically create the formula for us. If we select one of these cells, we'll take a look at cell F8. We can see that Excel has correctly filled the formula for us. And this works because Excel has identified the formula should be the value in column D for the current row multiplied by the value in column E for the same row. And we'll take another look at this shortly with another example. Next, our company also wants to be able to see for each employee what their tax contribution is. And this will be equal to their gross pay multiplied by the tax rate. And for this example, we will assume a flat tax rate of 20%. In cell L1, we'll go ahead and enter the tax rate. We'll add the number here as 0.2 and then we'll format this number as a percentage. So with our cell selected, we can go here to the number group on our home tab, and here we have the percent style. So go ahead here and click this, and that will format our number as a percentage. And very quickly to the left of this, we'll also add a quick description of what the cell is. So again, moving to the left by one column with Shift plus Tab. Now that we've added our tax rate, let's create a new column called tax contribution. Below this, in cell G2, we'll add our formula, and again remembering to start it with the equal sign. And then inside this cell, we'll multiply our gross pay in column F2 by our tax rate in cell L1. And again, Excel has automatically calculated the answer for us. Bring over a calculator just to verify. And yet, as we can see here, the answer is correct. Now, as mentioned, we'll take a closer look at how autofill works with functions, formulas, and cell references. So let's take the formula that we just created and use the autofill handle to extend it down for the rest of our employees. Now, the result here we get may not be what we were expecting. You'll see that for all the other rows, the calculated answer is $0. And as I'm sure we all know, a $0 tax contribution seems quite unlikely. So let's have a look at what's going on here. If we double click on our second formula, we'll see that the cell reference is incorrect. And to be more specific, we'll see that the tax cell reference is incorrect. So Excel is trying to multiply our gross pay here by the contents of cell L2, which is actually currently blank, or in other words, is 0. And if we look at another cell, we'll see that the problem persists. So looking here at cell F6, we can see that it's correctly identified the hours worked, but this time again, it's trying to multiply by the contents of cell L5, which obviously, again, here again, is blank. And the reason this happens is due to something called absolute and relative cell references. Let's take a look now at what absolute and relative cell references are. As we know, in Excel, a cell reference is a way to identify and locate a specific cell by its column letter and row number. A relative cell reference adjusts itself so that when you copy a formula or function to a different cell, the cell references change. Let's look at an example. In a new worksheet, I'll go ahead and enter a few numbers. In cell A1 and B1, I'll enter the numbers 5 and 10, and then in cell A2 and B2, I'll enter 15 and 20. Let's now add a formula into cell C1 that is equal to A1 plus B1. And the answer, as you'd expect, is 15. If we now drag this formula down to cell C2, you'll see that the formula changes. So now, rather than being A1 plus B1, it's changed to A2 plus B2. And that's because the formula we have used uses relative cell references. If you wanted a cell reference to remain constant, regardless of where you copy the formula to, you would use what's called an absolute cell reference, and this is done by adding a $sign before the column letter, row number, or both. If now we replace our formula in cell C1 and we include a $sign before both the column letter and row number, and the same for B1 as well, and then copy the cell down, you'll see that we get the same result in cell C2, and that's because the formula is using the same cell references of A1 and B1, so it's not updated to use row 2. Currently, our cell references are relative. This is because if you look here in the formula bar at our cell reference, there is no $symbol before the column letter or row number. In our case, we need to make our tax rate cell, so cell L1, be absolute, so that it does not change when we use autofill. To do that, we'll add a $sign in front of the L and in front of the 1 in our formula bar. And this then instructs Excel to not change the cell reference so that when we copy it down, it remains fixed as cell L1. Let's also fill our formula down again, and it already looks a lot better. But if we take a look now at our actual formula, we can see that it is still referencing cell L1, which is the correct cell. I'd just like to also quickly show you a shortcut to quickly turn a cell from relative to absolute and back again. So simply select your cell reference here in the formula bar, and then press F4, and this will toggle the $symbol from your cell reference. So you can quickly change it to either be relative, absolute, or back and forth. Before moving on, there's just a couple of little things that we should change. Firstly, our tax contribution column is overflowing slightly, so we'll go ahead and change that. Next, I also want to change the order of our columns slightly, so I'd like to swap our hours worked and hourly pay column around so that hourly pay is in column D and hours worked is in column E. We'll start by resizing our tax contribution column. Just like we did before, we'll hover over the line between our two columns, and then we'll double click when the arrow appears. Next, we'll change the order of our columns. I'll start by selecting the entire column, so I'll select column E by clicking on the column letter identifier, right click and hit cut. I'll then select column D, right click again, but this time we'll hit on insert cut cells. And this is a very easy way to change the order of cells within a spreadsheet. Now that we've added some formulas to our spreadsheet, let's take things a little further and add in our first functions. And the first function I'd like to show you is the sum function. And this can be used to add up all the values in a cell range. Let's say that we want to add up all the hours worked and gross pay for each of our employees. We'll go down to the bottom of our spreadsheet. Below column E that has our hours worked data, we'll add the sum function. And like formulas, we need to start our function with an equals. So equals, and then our function name, which is sum. And as soon as you start typing, Excel will try and find and autocomplete the function for us, and there it is. It suggested that we might be looking for the sum function, but also provides a description of what the function does. So Microsoft describes this function as adding all the numbers in a range of cells, and that is exactly what we need to do in this situation. After typing the function name, we'll then need to open a set of parentheses so that we can enter our arguments, or in other words, what data we want the function to work with. And to be helpful, Excel also provides us with some guidance on what information it's expecting. So here, it wants a number followed by a comma and then one or more numbers. We'll start by putting a 10, a comma, and then a 5. So we'll then close our parentheses, hit enter, and then Excel will automatically sum these numbers for us. In our case though, we want to add a range of cells for our column. So let's go back to our function and then add our cell range. Our first value is in cell E2, so we'll add E2 followed by a colon and then our last row, which is cell E15. And then now, when we hit enter, it'll sum all these values for us. You also do not need to explicitly close your parentheses, as Excel does this automatically. Now, instead of entering these cell references manually, we could also have clicked and dragged with our left mouse button. Let's quickly now add a line in between our data and our functions so that they are separated. We'll select the bottom row of our dataset, and then on our home ribbon on the font group, we have the border command. So click on this, and then we'll select the bottom border. This will then add a line beneath our actual data and our functions just so they're separated. And let's again now use the autofill handle and drag the function across to calculate the sum of our gross pay and our tax contribution. And if we quickly check the function, we can see that the cell references have automatically been adjusted, and this is because these are relative cell references. So sum is just one of many functions in Excel. We'll now use another function to calculate the average value for each of our columns, and this function we'll use is called average. And we'll add our average here below our current sum. Before that though, I'll quickly add in a label to just show what each of these rows represent. So add sum in here, and then below this we'll just add in average. Apply bold formatting just to signify these are headings. So let's go to cell E17, then initiate our function with the equals, and this time we'll call the average function. So is equal and then average, and then the description here tells us the function will return the average arithmetic mean of the arguments. So let's add in our cell range, but it's important here to not include the calculation from our sum. This will affect the average of our data. That's a good reason why you should add in the line to separate our summary functions from our actual data. And let's again quickly drag over the result of the average function over to the other columns. Hopefully here you can see how Excel allows us a quick and easy way to extract a lot of useful information from a dataset. Then the two final functions I'd like to go over today are the min and max functions, and these functions return the smallest and largest numbers in a range of cells respectively. And I'd like you to go ahead and try add these functions to the spreadsheet for the hours worked, gross pay and tax contribution columns like we've done up until this point. So the functions here, as you can see on screen, are simply called min and max. Just go ahead and pause the video and we'll come back in a few moments when you've tried this. Okay, so I hope you managed okay with that, but if not, don't worry, we'll go through the solution now. We'll start by adding our min function. So like usual, we'll start with our equal sign, and and then we'll write out the name of the function, which is min, and then we'll add our cell range, which is the same as before, and again, making sure to not include the results of either of our other two functions, and then go ahead and hit enter, and there is the answer. So we can see here that for the hours worked, 25 hours was the minimum value. Again, we'll go ahead quickly, just drag this across for our other two columns, so gross pay and tax contribution. So this is a very easy way of identifying the smallest number within a cell range. And then the process is the same for max, but of course we'll just change our function from min to max. Okay, good job everyone. So this is it for our lecture on formulas and functions inside of Excel. I hope you found this valuable. And this section here has covered everything you need to know about the basics and fundamentals of Excel, including how to enter data and work with some basic formulas and functions. In the next section, we'll build upon what you've learned about Excel in this section and look at some of Excel's more advanced data analysis tools and functionalities. So I'll see you in the next lecture.